Let us do a nice example here where we show how to write them. This is going to be my experiment. This is going to be my sample space. Then I'm going to choose some or other event. Then I'm going to see how many possible outcomes there are in this event, and I'm going to see how many possible outcomes in the sample space. So flip a coin. If I flip a coin, what are the possible outcomes? It could land on head or it could land on tail. Right? So that is my sample space. Event is the one that I choose, so I'm going to choose event E to be get a head. How many of these on the sample space are heads? 1. How many elements in the sample space? 2. Let's add one more thing. Probability of event E is then 1 over 2. Now think about it. It's pretty logic. If I flip a coin, chances of getting a head is 1 out of 2. We just say it without thinking. What if I flip 2 coins? Now I have to think of it in order. Even though we don't flip them both at once, you're going to flip one and then you're going to flip another one. So my sample space is they could both have been heads, head. Or the first time I could have had head and the second time I could have get a tail. Or I could first have gotten a tail and then a head. Or I could have had 2 tails. So notice head then tail is seen as different from tail then head. Right, what am I going to make my event? Get at least 1 head. Right, so what does this consist of? I'm actually going to write them out here. I could have had head, that's at least 1. I could have had head, tail. I could have had tail, head. So that is 3 there, whereas S has 4. So the probability of that event is 3 out of 4. Let's toss a die. Now, I know we generally say a dice, but dice is actually the plural, so a die is the singular. What could I get? I could get a 1, 2, 3, 4, 5, or a 6. I'm going to say my event is get an even number. So that would be 2 or 4 or a 6. So there are 3 values in my event. There are 6 values in my sample space. So this is 3 over 6, which simplifies to a half. Well, think about it again. The even numbers are exactly half as many as all the numbers. Let us do another toss a die. So I'm not going to fill in S again, it's the same. I'm going to make a new event. Just make a line here. Get a number that is higher than a 4. So what are the possibilities? I can have a 5 or I can have a 6. How many are there? 2, still 6. So 2 out of 6, which is 1/3. Right, let's do 2 more with toss a die. I just want to show you some more things here. So stick with toss a die again. And still the same here. I'm just not rewriting it. This one I'm going to say get a 10. Well, there are no 10s on a die. This is still 6. 0 out of 6 is 0. Right? So, what am I saying? If I toss a die, the chances of it landing on a 10, and it's a 6-sided die, is absolutely 0. Last one. Can we fit it in? No, I won't have space for that. We'll do that in the next one.